Yes, this is lesson 9. In this lesson, we are going to study about the graph of logarithmic functions and domain of logarithmic functions. In this lesson, firstly, we are going to learn the graph of logarithmic function. If you remember, I said logarithmic function is inverse of exponential function. So, if you derive the logarithmic function, logarithm base ax, if it's equal to y, if you derive the function x is equal to a to the power of y, it's going to be, when x is alone, the function that you find, it is inverse of it. So exponential form is the inverse of the logarithmic function. Here it shows the graph, shows the inverse function. Y is equal to x line is the definitive line here for the inverse. With respect to y is equal to x line, the function, it should be symmetric. If you see, it's getting closer to y is equal to x line, and this function is getting closer. If this is a to the power of x, if this is a to the power of x function, this function is inverse of it. Logarithm base ax it should be. And here, for the existence of logarithmic function, we should be careful about some part here. Firstly, a must be what is written here. A must be greater than 0, and a cannot be equal to 1. This is the second part. And the third part here, x must be always greater than 0. Okay. To draw the graph of the logarithmic function, logarithm base 2x. Here we need to be careful about the x values that we are choosing, because x must be greater than 0 always. So I'm going to choose x values with respect to this information. Here the base is 2, that's why I'm going to choose the numbers which are related with 2. So I'm going to start with 8, then I'm going to choose 4, x logarithm base 2x to 8 it's going to be, and I'm going to choose 2, I'm going to choose 1, then I'm going to choose 1 over 2, 1 over 2, 1 over 4, and 1 over 8. 1 over 8. These values I'm going to choose. Okay, then what will the logarithm base 2 y is equal to logarithm base 2 8 it should be. Here this is equal to logarithm base 2 cube, and 3 comes in front of the logarithm base 2, and this is equal to 1. So the answer is 3. The coordinates of the point is 8, x is equal to 8, y is equal to 3 is going to be. Okay, y is equal to logarithm base 2 4 is going to be equal to logarithm base 2 square is equal to 2 logarithm base 2. This is equal to 1. Then it's going to be equal to here 2, and the coordinate is going to be 4n. Okay, now we found the points, coordinate of the points. Here I'm going to locate the points. The first value is when x is equal to 2, when x is equal to 2, y is equal to 1, so the coordinate is here. And when x is equal to 4, When x is equal to 4, y is equal to 2. The coordinate is here. When x is equal to 8, y is equal to, I'm talking about this one, x is equal to, y is equal to 3 here. So the intersection point, it should be here. When x is equal to 1, when x is equal to 1, y is equal to 0. It's going to pass through this point. When it's equal to 1 over 2, which is half, so it's equal to minus 1. When it is half of 1 over 2, it's going to be here. And when it is more closer, this point, it's going to be minus 3. 1 over 8 is half of 1 over 4. So if we draw the graph of the logarithm base 2x function, here it's going to be something like this. It's going to be curve again, and this is the graph of logarithm 2x. Y is equal to logarithm 2x function. It's going to be okay. Here we are going to try to understand again the inverse of logarithmic function, exponential function. This is logarithmic function. Here the graph, what is here, as you understand, this is the logarithmic function, and this function is the exponential function. So when you change the base here, let's say if it is equal to 3, here, as you see, when it gets closer to x-axis, this curve gets closer to y-axis, because they are symmetric with respect to this line. Here, when you draw one perpendicular line to this one, the distance between two graphs, it should be same to the y is equal to x line. Okay, then when you come to this point, or when you come to this point, as you see, it's getting closer to x-axis, and this graph which is exponential graph, is getting closer to y-axis. Here the a value is greater than 1. Here a value is between 0 and 1, but a will never be equal to 0. We need to understand that one also. Here when you see, this is like logarithm 1 over 2x, logarithm 1 over 2x. This is 1 over 2 to the power of x, or 2 to the power of minus x function. Okay, as you see, they are symmetric also here. Yes, here these are the graph of the logarithm 4, 3 and 2. When the base is increasing, it's getting closer to x-axis, I said. If I show this one on the Desmos calculator, graphing calculator, here logarithm base 2x, it's going to be here in this form, and logarithm base 3x, which is closer to x-axis, and the 4x must be closest one, as you see here. Yes, the logarithm base 4x, the closest one is going to be. Okay. If we close this one, if we continue with the domain of the logarithmic function, domain of the logarithmic function, where the function is defined here, we should check this case, existence of the logarithmic function. The logarithm base a fx function, fx must be greater than 0. So we are going to check this one is greater than 0 or not, or we can say like this, for the find the possible largest domain. When it says we are going to find x is greater than 0, or x squared plus x minus 2 is greater than 0, or 2x plus 8 is greater than 0. This part I'm not going to solve now, because this is quadratic inequality in next question. So I'm going to solve this one here directly. I'm going to solve this too. So fx must be greater than 0 for the domain. X must be greater than 2. This is the solution now. And if we notate this one as an interval, open, it's going to be because the sign is greater than 2 to infinity is going to be, and here 2x is greater than minus 8, x is greater than minus 8 over 2, x is greater than minus 4 is going to be. Here the logarithmic basis not important because their number, if it is greater than 0 and not equal to 1, it means that our logarithmic function exists. Numbers, these should be greater than 0 again. X squared plus 4x minus 5 must be greater than 0, and 16 minus x squared, these are greater than 0. All these are quadratic inequalities, and we learned from the previous page quadratic inequalities we are solving with tables. So greater than 0, x squared, x we are going to factorize. Here this is going to be plus 2 and minus 1. X plus 2 times x minus 1 is going to be greater than 0. The sum of them is plus x. The crossly when you multiply 2x minus x, and multiplication of them here, this 2 is going to be minus 2. So x1 is equal to minus 2, x2 is equal to 1. When I draw the table here, minus 2 here, 1 it should be here, this side is minus infinity side, this side is plus infinity side. I'm checking the sign of the x squared. I'm going to start from the right side, and if this sign is plus, then this sign is going to be plus, minus, and plus here. Then minus infinity, I'm looking for greater than 0, this part is greater than 0, this part is greater than 0. So the solution set is x is element of minus infinity, minus 2, this is open and this is open because the question is asking greater than 0, union 1 to infinity is going to be. Okay, what about x squared plus 4x minus 5? Again, we are going to factorize. If we can factorize, we are going to factorize. Here, x squared and plus 5 and minus 1 is going to be the factors. X squared we can separate as an x. We can separate as an x and x. We can factorize as an x and x. X plus 5 times x minus 1 is equal to x plus 5, x times 5 is equal to 5x, x times minus 1 is equal to minus x, so 5x plus minus x is going to be 4x. So this factorization is true. X plus 5 times x minus 1 is greater than 0. The critical points x1 is equal to minus 5, x2 is equal to 1 is going to be. If we draw the table again, here, this is minus infinity side and this is plus infinity side. It's going to be here minus 1 and minus 5 and 1, they are going to be here. The sign of x squared I'm checking, it is plus, so I'm going to start with plus, then minus, then plus. It's going to be plus, minus, plus. Order is also important. Then here is going to be greater than 0, so the interval is going to be x is element of minus infinity minus 5 union 1 to infinity. 16 minus x squared is greater than 0, so we are going to factorize 4 minus x and 4 plus x is greater than 0. It's going to be 4 minus x. If it is greater than 0, 4 x1 should be equal to 4, x1 should be equal to 4, and x2 it should be equal to minus 4. And if we draw the table here, minus 4 is going to be here, 4 is going to be here, minus infinity here on this side, and plus infinity on this side. It's going to be the sign of x squared I checked and it is minus, so this is going to be minus, this is going to be plus, and this is going to be minus. Minus plus minus this time. Here it was plus minus plus, and we are looking for greater than 0. Greater than 0 interval is this one, so the x is element of between minus 4 and 4. Both of them it should be open because this is greater than 7. Okay, now logarithm base x squared minus 1. X squared minus 1 should be greater than 0. This is greater than 0, sorry. Greater than 0. This is the first case, but here we have also one more condition. X, which is base here, also must be greater than 0. So we are going to get the solution of both of them. X squared minus 1 must be greater than 0. Then here we are going to factorize x minus 1 times x plus 1 is going to be greater than 0. X squared minus 1 squared it is. X1 is equal to 1, x2 is equal to minus 1. We are going to make the table. Quickly I'm doing in our tables. Minus 1. The sign is plus, so it's going to be plus, minus, then plus. If it is minus, I'm repeating this part again, sorry. Minus, this one is going to be plus, then this one is going to be minus. This side is minus infinity, this side is plus infinity side, and the results here greater than 0 part. So the x is element of minus infinity, minus 1, union 1 to infinity. Here x is greater than 0. So we are going to combine these two cases. Case 1, this is case 1, and this is case 2. Case 2. How we are going to combine these cases? First I am going to draw the graph of the minus 1 infinity, which means this side, and this should be open, and 1 to infinity, which is open, and to this side is going to be. Then 1 to infinity, and the second one is here, the second case, this is case 1, and this is going to be case 2 here. That's greater than 0, x is greater than 0, so it's going to be to this side. And now the solution is the intersection of both of them. Because if you choose the x is negative number with respect to, if we solve the question only with respect to this one, you may choose negative number, because it says between minus infinity and minus 1 is possible for this one. But for this function, which is equal to x, it's going to be negative. This function is going to be negative, and it's going to be undefined. So common part, this part, and we are writing the last one. X is element of 1 to infinity, it must be.